The purpose of this PowerPoint presentation is to analyze the price elasticity of demand. And basically, what the price elasticity of demand is, it's an attempt to find out how sensitive consumers are to price changes. To put it into our microeconomic language, if a firm changes its price, how will consumption change? In other words, if a firm changes its price, how will quantity demanded change? The most general equation to mathematically calculate the price elasticity of demand is the following. E, which from now on will represent the price elasticity of demand coefficient, is equal to the percent change in quantity demanded divided by the percent change in price. And of course, we have the ceteris paribus assumption that goes with this equation. So the percent change in the price, that is the cause. And the percent change in quantity demanded, that is the result. Just keep in mind that the coefficient E, which represents the price elasticity of demand, that it is not a monetary value, that it is not a percentage. What the price elasticity of demand is it's a coefficient, it's an index number which measures the relationship between the cause and the effect. The cause in this case being the percent change in price, and the result, the consequence, being the percent change in quantity demanded. In other words, how do consumers react to price changes? A more specific equation to calculate the price elasticity of demand, or the E coefficient, is the following. And keep in mind that this is the arc, or the segment price elasticity of demand calculation. In other words, it looks at a segment, a portion of the demand curve. So the equation is, in the numerator, QD2 minus QD1 divided by QD2 plus QD1 divided by 2. Why are we dividing by 2? We're dividing by 2 because we're looking at the average elasticity along the segment of the demand curve. Now, in the denominator of this equation, we have the percent change in price, which is the cause. So there, as you see, we structure it this way: P2 minus P1 divided by P2 plus P1, and in turn that gets divided by 2. Why are we dividing by 2? Well, again, because this particular price elasticity of demand is called the segment or arc elasticity of demand, and it looks at a segment of the demand curve. So we're trying to calculate the average of this, the average elasticity of this segment. What I just said, you're going to see graphically in the next frame. What this slide shows is the idea of the price elasticity of demand, which is the segment or arc elasticity of demand. In other words, we're looking at a segment of the demand curve. That segment, which incorporates the difference between P1 and P2 and between QD1 and QD2. And by the way, it doesn't matter whether we go from P1 to P2 or from P2 to P1. The calculation, the interpretation, is going to be identical. Okay, so your company has spent a lot of money to determine its price elasticity of demand. So in this case, their calculations showed that the price elasticity of demand is equal to negative 0.4. So what exactly does this mean? Well, it means the following. If price increases by 1%, where did I get the 1% from? I didn't calculate it. It's not a calculation. I have arbitrarily chosen 1 as my number of convenience to use to explain the concept of the price elasticity of demand. So the 1% is, again, a number of convenience. I could have chosen a different number, obviously, but why complicate things? Normally, my numbers of convenience will be either 1 or 10. And again, it's not a calculation. I've arbitrarily chosen 1% or 10% because these numbers are easy to deal with. So, back to what I was saying. We're trying to interpret this negative 0.4. So what exactly does it mean from the perspective of price and QD? It means the following. If the price increases by 1%, then quantity demanded will decrease by 0.4%. You see the law of demand in effect, right? As the price goes up by 1%, the quantity decreases by 0.4%. That's what that negative number, that's what that negative sign means, that there's an inverse or negative relationship between the cause, price, and the result, quantity demanded. So on the next line there, we see if the price decreases by 1%, then what happens to QD? How do consumers react? Consumers will react by increasing their quantity demanded by 0.4%. And what if the company wants to increase its price by 10%? Well, in this case, quantity demanded would decrease by 4%. All that we need to do is to take the price elasticity of demand coefficient and multiply it by 10, because we must maintain the symmetry. And finally, the last illustration, if price decreases by 10%, quantity demanded will increase by 4%. Let's take another example. Once again, what I'm doing is showing you how to interpret the price elasticity of demand coefficients. So in this case, the price elasticity of demand coefficient is negative 1.3. So if the price goes up by 1%, again, where the hell did I get that 1% from? It's not a calculation. Again, I have arbitrarily chosen 1% as my number of convenience. So if the price goes up by 1%, quantity demanded will go down by 1.3%. And if the price goes down by 1%, quantity demanded will go up by 1.3%. And if we increase the price by 10%, quantity demanded will decrease by 13%. Again, we must keep the symmetry. So what we've done is we've multiplied 1.3 times 10. So all we did was shift the decimal point. one space. And finally, the last one. If the price decreases by 10%, quantity demanded will increase by 13%. The next step is for me to walk you through all 5 types of the price elasticities of demand. We'll start with perfectly inelastic, then inelastic, then unit elastic, then elastic, and then perfectly elastic. At this point, let me give you examples of what a perfectly inelastic price elasticity of demand is. Mathematically, it would be this. P for price, E, that's the coefficient, price elasticity of demand coefficient. D, well, D just telling us that we're dealing with consumers. So mathematically, a perfectly inelastic demand would be shown by the coefficient of 0. I'll explain that as the lecture progresses. For the second type, inelastic, we would show the price elasticity of demand in this way. Inelastic, negative 0.4. All right? I'll explain later what this means. Unit elastic. Unit elastic would look like this. Again, P for price, E for elasticity, and D for demand, meaning we're dealing with consumers. Unit elastic would be shown this way, negative 1.0. All right. Elastic, that's fourth category, the fourth type, would be shown this way. That's an example of elastic price elasticity demand. Negative 2.4, let's say, right? So that's an example of elastic price elasticity of demand. And the last one, number 5, perfectly elastic. Well, that's a strange one, which I'm going to have a hard time explaining. All right. So how would we show that? Price elasticity of demand is equal to, all right, brace yourself, negative infinity. And at this point, that's all I want to say about perfectly elastic demand. First type of price elasticity of demand, perfectly inelastic demand. What does that mean? It means that consumers are totally insensitive to price changes. Price goes up, price goes down, quantity demanded will not change. So, as I already pointed out, the coefficient for a perfectly inelastic demand is equal to 0. All right? So let me go through the 5 illustrations here. If the price goes up by 1%, again, where did I get the 1% from? I made it up. It's a number of convenience. So if the price goes up by 1%, quantity demanded does not change. If the price goes down by 1%, quantity demanded does not change. If price goes up by 10%, what happens? Consumers do not change their behavior. Quantity demanded does not change. If price goes down by 10%, what happens to quantity demanded? Again, it does not change. What kind of a product is this, you think? now we come to the shape of perfectly inelastic demand curve. Well, as you see, it's vertical. It's perpendicular to the x-axis. Again, what that means is price goes up and nothing happens to quantity demanded. Price goes down and nothing happens to quantity demanded. Let's see if I can draw this here. All right. So this would be quantity demanded. So let's start with P1. At P1, what's quantity demanded? It's this quantity demanded here. If the company raises the price, what happens to quantity demanded? Does not change. If the company decreases the price, what happens to quantity demanded? It stays at QD. Again, I posed the question, what kind of a product could this be? Here, what I'm going to try to do is to explain the relationship between perfectly inelastic demand and total revenue. Just keep in mind that we're defining total revenue by P times QD. All right, so let's see. If the price goes up by 1% and quantity demanded does not change, well, what happens to total revenue? Well, price goes up by 1%, QD does not change, TR increases. In the second example, if price goes down by 1%, quantity demanded does not change. So what happens to total revenue? Well, price goes down, quantity demanded does not change, TR goes down. If price goes up by 10%, again, QD will not change. There's no reaction by the consumers. What will happen to total revenue? It'll go up. Although QD does not change, price did go up, thus pushing up total revenues. And in the last illustration, if the price goes down by 10%, again, QD does not change. What does that do to total revenues? Total revenues decrease. That's the meaning of price elasticity of demand equaling to 0. There's no reaction by the consumers. So what kind of a pricing strategy should the company engage in? Should it increase or decrease the price? Well, obviously the perfect price strategy here would be to increase the price in order to maximize total revenues. We're not dealing with profits yet. We're dealing with total revenues, so we're attempting to maximize total revenues. And now we come to the second type, inelastic demand. But before we go any further, I just realized that this is wrong. So let me make the correction. The correction is the following. Okay. So this is correct. This is the correction. All right. So let me explain the correction. All right. E is the coefficient. It's the price elasticity of demand coefficient. In our case, it is going to be negative 0.8. Now, you see these bars, right? these bars in mathematics, they mean absolute value. And what an absolute value is it takes a negative number and it turns it into a positive number, right? So what we're saying here is that 1 is greater than it being our price elasticity of demand coefficient, in our case 0.8, and it is greater than 0, right? 0.8 is indeed greater than 0. All right, now, what is the significance of inelastic demand? Well, it means that consumers are sensitive to price changes by a little bit. That's not a very scientific number, is it? The little bit means that the change in price will bring about a smaller change in quantity demanded. All right, let's try. So we are interpreting a price elasticity of demand coefficient, which is negative 0.8, and which we know is inelastic. So what does it mean? It means that if we increase the price by 1%, quantity demanded will decrease by 0.8%. And if we decrease the price by 1%, then quantity demanded will go up by 0.8%. On the other hand, if we increase the price by 10%, quantity demanded will go down by 8%. And if we decrease the price by 10%, quantity demanded will go up by 8%. All right, so that's the meaning of inelastic demand. I have 2 more slides which follow. Shape of inelastic demand curve. It's steep as opposed to flat. More precisely, it's relatively steeper. All right. All right. So what exactly does that mean? Let's see. Steep demand curve like that. Here's the price. Here's the appropriate QD1. We increase the price by a lot, let's say. And what happens? QD does indeed decrease. In other words, consumers are sensitive, but they are sensitive by a little bit. Right? And if we drop the price from P1 to P3, what happens? Well, quantity demanded is going to go up by a lot or by a little bit? By a little bit. And I wonder what kind of a good this is. What kind of what types of goods fall under the heading of inelastic demand. And now we get to show the relationship between inelastic demand and total revenue. Again, what is total revenue? Well, here's the equation. Total revenue is equal to price times quantity demanded. So we want to know what the relationship is between a price change, quantity demanded, and then in turn, what happens to the total revenues which the company is generating. So case in point, we're using this coefficient here. E is equal to negative 0.9, which is inelastic, isn't it? So, interpretation time. If the price goes up by 1%, quantity demanded will go down by 0.9%. And what happens to TR? TR will increase. Up by 1, down by 0.9. Which is the stronger effect in this case? It's the price effect. The second example, if price goes down by 1%, then quantity demanded will go up by 0.9%. What's going to happen to TR again? TR in this case is going to go down. What's the logic here? Well, price goes down by 1%, quantity demanded goes up by 0.9%. Which is the stronger effect, the price effect or the QD effect? Again, it's the price effect, and that explains why total revenues decrease. Third example, price goes up by 10% in this case, as opposed to 1% or 2% or whatever percent. So the price goes up by 10%, and what happens to quantity demanded? It goes in the opposite direction. It goes down by 9%. And what happens to TR? TR, like in this example, increases, because the price effect is stronger than the quantity demanded effect. And finally, the last example, the last illustration. If price goes down by 10%, what happens to QD? QD will go up by 9%. So, down by 10, up by 9, which is the stronger effect? The price effect. Therefore, TR will decrease, which is similar to this example here. And again, I wonder what kind of products these are, these inelastic demand products. And now we come to type 3, unit elastic demand. And there, as you see, the price elasticity of demand coefficient is equal to negative 1.0, and in absolute value terms, you see those bars again, right? Those bars, that means absolute value. It's equal to 1.0, right? When we do the mathematical calculations, we leave the negative number in. However, when we interpret these coefficients, we tend to use the absolute value numbers. Now, what's the significance of unit elastic demand? Well, one way to describe it is to say consumers are sensitive to price changes in a symmetric way. That is, the change in price will bring about an identical percent change in quantity demanded. All right, so what does that mean? It means the following. If price goes up by 1%, what will happen to quantity demanded? It'll go down by 1%. Up by 1, down by 1. If price goes down by 1%, what happens to quantity demanded? It goes up by 1%. Again, an identical percent change. If price goes up by 2%, what happens to quantity demanded? It goes down by 2%. If price goes down by 2%, quantity demanded goes up by 2%. And finally, if price goes up by 10%, what happens to quantity demanded? It goes down by 10%. And finally, the last one, if price goes down by 10%, what happens to QD? It goes up by 10%. All right? So, price elasticity of demand is equal to negative 1.0. Shape of unit elastic demand curve. Well, in this case, we're doing linear models, so these are straight lines. Well, what can we say about a unit elastic demand curve? It's neither steep nor flat. It's neutral. This is how I've been drawing these curves all throughout the course so far, in a very neutral way. I don't know what else to say about it. That's it. Neither steep nor flat. Neutral. Oh, we forgot something here. A market. Always label your market. Here we are linking unit elastic demand and total revenue. Again, what is total revenue? It's price times quantity demanded. So, interpretation of this price elasticity of demand coefficient, which is equal to negative 1.0. If the price changes, this will have an effect on QD, and in turn, this will have an effect on total revenues. So, let's do the first one here. If price goes up by 1%, QD will go down by 1%, up by 1, down by 1. What happens to TR? No change. If on the other hand, the price goes down by 1%, well, that means QD will go up by 1%. So what happens to total revenues? Again, no change. If price goes up by 10%, well, then QD will go down by I didn't put this down. Oh, another boo-boo. 10%. I forgot to put that in. 10%. So up by 10%, down by 10%. What happens to total revenues? No change. Last illustration. If the price goes down by 10%, QD will go up by 10%. And what's going to happen to total revenues? No change. So what would be the appropriate price strategy here? To increase or decrease the price? Probably to leave the price alone. My question again is, what kind of a product is this? Type number 4, elastic demand. And here I have set limits to the price coefficient. Infinity is greater than it, and it in turn is greater than 1. Here we're using negative 1.1. Let's see if it fits into this limitation. So here the absolute value of negative 1.1 would be 1.1, and it is true it is greater than 1, and it is also true that infinity is greater than 1.1. Okay, so how do we verbalize this elastic demand? Well, we verbalize it in the following way. Consumers are sensitive to price changes by a lot, as opposed to a little bit, a lot. And that means the change in price will bring about a greater change in quantity demanded. In other words, consumers are sensitive to price changes by a lot. All right, let's try it here. Again, we're interpreting negative 1.1. So, example 1 here. If price goes up by 1%, what happens to QD? QD goes down by 1.1%. If price goes down by 1%, then quantity demanded will go up by 1.1%. If price goes up by 2%, if the price goes up by 10%, QD will go down by 11%. Again, all we need to do is multiply by 10. We have to multiply E by 10. We're just moving the decimal point, one space. And the last one, if the price goes down by 10%, what happens to QD? QD increases by 11%. All right. I wonder what kind of products these are. Shape of elastic demand curve. Well, it's flat. It's flat as opposed to steep. Okay. Here we would put a D, and obviously here's the market. Okay, so let's see. Steep demand. So let's say this is the initial price. Well, at this initial price, where is QD? Right there. If the price goes down by a little bit from P1 to P2, what happens? QD increases by a lot. So as you see, which is the greater effect? The price effect or the quantity demanded effect? It's the quantity demanded effect. Okay, now let's go to the next. Frame. And as we've been doing all along, this is no exception. We draw the link between elastic demand and total revenue. Again, what is total revenue? There you are. Total revenue is equal to price times quantity demanded. So we're going to use this price elasticity of demand, negative 1.5, which is elastic. So our quest here is to explain the relationship between price, quantity demanded, and total revenues, and then come up with a decision as to whether the firm should increase or decrease the price. So let's do the first one. If the company increases the price by 1%, what's going to happen to quantity demanded? Quantity demanded is going to decrease by 1.5%. So what happens to TR? TR will drop. Second example, if the price goes down by 1%, what will happen to QD? QD will go up by 1.5%. So down by 1, up by 1.5%. What happens to TR? TR increases. So this must be the correct pricing strategy. If your company has a consumer base which is showing elastic demand, the correct price strategy is to decrease the price and not increase the price. All right, let's do it. Let's do it one more time. If the price goes up by 10%, quantity demanded will go down by 15%. So up by 10, down by 15. What happens to total revenues? They go down. If the price goes down by 10%, then QD will go up by 15%. And what will happen to total revenues? They'll go up. So this seems to be the correct pricing strategy, just like this example here. And again, I wonder what kind of products these are. Type number 5, perfectly elastic demand. So here we have the price elasticity of demand coefficient equaling to, in mathematical terms, equaling to negative infinity. And in absolute value terms, equaling to, equaling to infinity. All right? How do we explain perfectly elastic demand? Well, it's not easy. We will only come across perfectly elastic demand in our analysis of pure competition, which will be a lecture in the very near future. So for a fuller development of perfectly elastic demand, I would rather wait for the analysis of pure competition, because it's going to make a lot more sense in that context than in this very theoretical context. Just remember that perfect elastic demand basically means that if the price goes up, then QD will change in an infinite way, and if price goes down, quantity demanded will also change in an infinite way. And I don't dare to speculate about what happens to total revenues. So let's leave it at that, okay? Perfectly elastic demand. Again, I will go through perfectly elastic demand in the context of something more solid, which is a pure competition market structure. Problem 1, that's a numerical problem, all right? Here you have the given, okay? Let me take the given and connect it with the diagram, which I'm about to draw here. A market, okay, price, QD, demand curve. So what do we have here? We have P1, which is 10. We've got QD1, which is 100. And we have P2, which is 9. And we have QD2, which is equal to 110. And what we're doing is we're calculating the price elasticity of demand along this portion of the demand curve. So that's going to be the average. Whatever this number is, the price elasticity of demand coefficient, it will represent the average elasticity along that segment or arc of the demand curve. So again, we'll be using this equation here. And what we're trying to do is we're trying to calculate the price elasticity of demand. Okay, the solution is in the on the next frame. Well, here's the solution. All right, 110, that's QD2. 100, that's QD1. And here we add QD2 and QD1 and we divide by 2. Again, why do we divide by 2? Because we're taking the average along that segment of the demand curve. And here we did the same thing for price. It's P2 minus P1 divided by P2 plus P1, and once again we divide by 2 because we're taking the average. So this numerator part, this is the percent change in QD, and this denominator part, that's the percent change in price. And of course, ceteris paribus. What is the cause? It's the change in the price, which is the cause. What is the result of the consequence? It's the percent change in quantity demanded. It's the change in the behavior of consumers. So how do we interpret this number here? Negative 0.91. Is it elastic or inelastic? It's obviously inelastic because it's lower than, in absolute values, it's lower than 1. So what should our pricing strategy be? Should we increase or decrease the price? I forgot what the answer is, but you know the answer. Problem 2, and on the next slide, the solution. So the given, the Acme Corporation is planning to increase its price by 10%. Acme's price elasticity of demand is equal to negative 1.2, which makes it elastic, right? If we take the absolute value of it, we'll get 1.2. If we compare it to 1, which is unit elastic, it's higher than 1, so it must be elastic. This is elastic demand. And what we're asked to do is to calculate the change in total revenue. Now, before you start, you should realize that we do not have P1, we do not have P2, we do not have QD1, we do not have QD2. However, we do have the price elasticity of demand, which is equal to negative 1.2, and that coefficient is very revealing. Another way put, our answer is going to be given in terms of a percent change in total revenues. All right? Okay. Now, let's go to the next frame, which gives us the solution. And now for the solution. So let's take it step by step. Step 1. If the price goes up by 10%, as the company wants to do, then quantity demanded will decrease by 12%. Well, how do we know that quantity demanded will decrease by 12%? Because we're told that the price elasticity of demand is equal to negative 1.2. All right? Now, step 2. So what are we doing in step 2? In step 2, we're constructing equations that we can use in order to solve the problem. So we start with TR1. So what is TR1? TR1 is P1 times QD1. What is TR2? TR2 is P2 times QD2. All right? And what is the change in TR? The change in TR is TR2 minus TR1. All right, so here we have composed these equations that we can use for our solution. Now, in step 3, we're going to decompose. So, we start with change in TR. As we've already seen, the change in TR is equal to TR2 minus TR1. What is TR2? Well, TR2 is P2 times QD2. And what is TR1? TR1 is P1 times QD1. All right? Now, once again, we don't have P1, we don't have P2, we don't have QD1, we don't have QD2. What we have, however, is knowledge that the difference between P1 and P2 is 10%, and that the difference between QD1 and QD2 is 12%. So coming back to the price differential, which price is higher? Well, P2 is higher than P1 by 10%. And QD2 is lower than QD1 by how much? By 12%. All right? So this is what we're going to do. Since we don't have P1, since we don't have P2, but we do know that the difference between P1, P2 is 10%, then we'll assume that P2 is 1.1 P1. That tells us that P2 is 10% higher than P1. Well, using the same logic for QD2, again, we don't have QD2, we don't have QD1, but we do know that Q1 or QD1 is higher than QD2 by 12%. All right? So, how do we interpret QD2? Well, it's 12% less than QD1, right? So, we phrase QD2 in the following way. QD2 is 0.88 QD1. In other words, it's 12% smaller than QD1. All right, that's this part here. And now, the next term, the minus. Well, what's the implied coefficient of P1? What's the value of P1? It's 1. The same thing applies to QD1. What is the implied coefficient of QD1? It's 1. So what's P1 times QD1? It's going to be 1. So what's the next step? Well, the next step is to multiply, and eventually what we get is 0.968 minus 1, and we have to multiply it by 100. Why do we have to multiply it by 100? Because we want a percent. So here's the answer. The answer is negative 32%. So if the firm increases the price by 10%, its total revenues are going to go down by 3.2%. So this would not be the suggested price strategy.